Hi, the topic is iterative and recursive algorithms. So in this tutorial, we are going to define what is iterative algorithms and a recursive algorithms, okay? And we are also going to take some example to fully understand these concepts, which are very important as far as algorithm is concerned, okay? Definitely, you should not skip that, right? So be concentrate and everything will be okay. So let's go ahead and define what is actually a recursive and iterative algorithm. But before we jump into that, please make sure you have already subscribed to my channel. Also, you have watched the previous video, okay, so that you are not lost in this tutorial. So let's go ahead and define what is actually an iterative approach. So in this iterative approach, the function repeatedly runs until the condition is met or it fails, okay? So it involves the looping construct. So we have the loop, the for loop, the while loop, the do while, okay, and so on loops. So as we move forward and we take an example, then you get what we mean by iterative and looping construct, which is very easy, right? So here we are just using loops, okay, for loops, while loop. If you are familiar with C programming, definitely you should know what loops are, okay? But we will have one tutorial where we are actually going to explain, okay, these concepts in more detail. But as for now, just keep in mind that in iterative approach we use loops, okay, to construct or to design our algorithms. So if we take an example here, so suppose that we have a problem, okay, that a programmer has to determine the sum of the first n natural numbers, right? So we can have this function which can help us, okay, to achieve that iteratively, okay? That is, here we are actually using loops, as you can see there, okay? We are actually using the for loop, all right? So this one is actually an iterative approach by the mean of loops, okay? That's the iterative concept. We are using loops, okay, to perform a particular action or to write a specific algorithms, okay? So that will be the algorithm, okay, or this one is actually the C program to to do that, to solve the n first natural numbers, okay? That means the user is going to enter some numbers, okay? Of course we are going to talk about functions as we move forward, because this one is actually a function, all right? So that is the concept, okay, from I. So we first of all have two variables, I and s. S is initialized to 0, and then for loop. So the loop from I, okay, to 1, I less than, okay, or equal to n, increment I, okay, s receive s plus I, right? So if I is equal to, let's assume that the user enter, okay, because suppose that that number is actually positive, right? Of course this n is positive. So here for I equals to 1, let's just assume that there is 2, okay, n is equal to 2 here. So I is equals to 1, 1 is less than 2, yeah. So s receive s plus I. So s receive s, what is s first? 0, 0 plus I, which is 1. Then go back and increment I, right? So of course when you add, you assign back that value to s. That means s now is 1. Then we increment I becomes 2. It goes, okay, 2 is 2 less or equal than 2, yes. So come here and execute this one again. So s receive s plus I, s receive what? 1, okay? Remember that s was now 1 plus 2, that is 3, okay? So that's how it is. And then after you are going through these loops, okay, iteratively, then go out and then return s, which is actually the sum, all right? So that's how iterative approach actually works, okay? And if you want to like analyze, okay, the time take, okay, by this algorithm to execute, right? First, remember that from previous tutorial we said that we may not want the exact number of steps, okay? We want the approximate time, and we use asymptotic notation, okay, to represent that. Remember from the previous tutorial, all right? So we have here, if this function is called f of n, how many times does this function take, okay, to execute? So we have here, this one can be taken as 1 times, okay, and this one, since is from 1, while I is less or equal than n, okay, we have this statement is going to execute, okay, n times, all right, n times. So that's how it is. Of course, we have another tutorial where we are actually going to explain all of this in more detail, right? So don't worry too much about that. So definitely we should have this n plus 1, or if you want to count, okay, to have the exact number of steps, you may have something like this, an plus b, okay. Actually there are some assumptions to count the number of operations, okay. So we can say that these, okay, statements that is separated by a semicolon is actually one instruction, okay. So this one, I receive 1, which initialize I to 1 is actually one instruction, I less or equal than, okay. So we are going to check this one actually n times, okay, and we are going to increment I n times 2, okay. So we can see that this for loops is also something like n. This one is n plus 1 because we need to check, okay, n plus 1 to make this one fails, right? Of course, don't worry too much about that because that is not the okay, the objective of this tutorial, okay. It's just to show the concept of iterative algorithms. So that's how it is, right? So definitely we should have this. So if the f of n, that is the time, okay, taken by that function to execute itself, we have this an plus b, we have a and b constants, okay. So the approximate number of operations is then, okay, this one an plus 1, then we take big O of n, remember from the previous tutorial. And of course we have another tutorial on asymptotic notation, okay, where we are going to talk about that into, okay, more detail, but you should have at least watched the, okay, previous tutorial. So we have here f of n belongs to the linear class, okay, function, remember. So recall from the previous tutorial, okay. So that's actually the time we actually take the highest, okay, power or the degree of the polynomial. Since this one is a linear, okay, class function, so we take the degree, the one that has the highest degree, okay, is actually this one. So we take then big O of n, as we are going to see later. So that's what we can say about iterative looping construct, okay, algorithms. So let's go ahead and talk about a recursion or recursive approach. So the process in which a function calls itself directly or indirectly is called recursion, and the corresponding function is called as a recursive function, okay. A function is nothing but, okay, something that allows us all to factorize our code to execute a specific task, okay. So we can have a function, as we saw just, okay, previously, this function to compute the, okay, the sum of the first n natural numbers, right? This one is actually a function. So a function has a name, okay, and it may take some parameters, okay, and a return type. As you can see, the return type is actually an int, the function name is sum, okay, and it takes an integer as parameter and then compute some, okay, things here. So that's what basically a function is, okay. So of course we have a tutorial where we are going to talk about function in more detail, but at least, okay, you get the concept. So we are saying that in this iterative approach, the function calls itself, okay, back, right, recursively, okay. That's what we mean by a recursion, okay. So some computer programming languages allow a module or function to call itself. So this technique is also known, okay, as recursion. We can say that, okay. So in recursion, a function A either calls itself directly or calls a function B that in turn calls the original function A. So the function A is called the recursive function, right? So that's what we can basically say about the recursion, the process of calling itself back, right? So before we take an example, let's actually see some properties of recursive functions, okay? So a recursive function can go infinite loop, okay, infinite like a loop, all right? So to avoid infinite running of recursion function, there are two properties that the recursive function must have. We have the base criteria. Those are the two main properties, okay, that a recursive function must have, right? Must, okay? So the base criteria, so there must be at least one base criteria or condition such that when this condition is met, okay, the function stops calling itself recursively. So, and the second one is the progressive approach. So the recursive calls should progress in such a way that each time a recursive call is made, it comes closer to the base criteria, right? So that's what we can see, okay, about the recursion, and those are the two properties, main properties, okay, that a recursive function must have, okay. So if you take the previous example, okay, so we want to also add the sum of the 100, or let's just say n first natural numbers, okay. So we can have this function, okay. The function will return an integer and the name is sum, and it takes an n as parameter here, okay. So we say now if n is equal to 1, then we return 1, alright. So of course, if n is equal to 1, we sum from 0 to 1, okay, we have 0 plus 1, which is actually 1. Else, if not, return n plus sum of n minus 1, okay. That is, it's going to return n and then call that function back again, but now with n minus 1, okay. So it's going to subtract till we reach 1, and then in the returns, okay. So it's going to, this one is actually the base criteria. As you can see, if n is equal to 1, that means the base criteria, remember, that means the function is going to stop calling itself when this n is equal to 1, okay. So of course here we are assuming that as n is a positive integer greater than or equal to 1, okay. It should not be a negative number. If n is a negative number, then definitely we are going to talk about that, okay, as in a minute. So this one is a base criteria. So if n is equal to 1, then return 1. If not, return n plus sum n minus 1. So just call the function back again, but this one subtract, okay, 1. So let's assume that n is equal to 3. So n is not equal to 1, so it's not enter here. Else l is equal to, okay, is 3, so we enter here. You return 3 plus sum of 2, okay. Go back again, call this function. You return what? 2 plus sum of 1, and then return what again? 1, okay. Call a function of 1 again and then return that, right? So that's how the recursive actually works. This one is the progressive approach. As you can see there, we're actually subtracting, because remember that n is a positive integer greater or equal than 1, right? So here, and we say that this, okay, since we are decrementing, we are actually tending to this n equals to 1, right, which is the base criteria when the function is going to stop calling itself when this condition is met, okay. So this one is the progressive approach. Remember that we said that the function, okay, the recursive call should progress in such a way that each time a recursive call is made, it comes closer to the base criteria, all right. So that's how, okay. But assume that here you do something instead like n plus 1. Actually you are incrementing, that means you never reach 1. That's what we call stack overflow, okay. That means the function will never stop calling itself until your RAM, okay, is, okay, you don't have more RAMs, then it's going to stop, okay. So you should avoid that kind of, okay, infinite executions, okay. So you should tend at least to the base criteria, remember from the previous, okay, explanation. So actually, how does this recursive function actually, okay, how does it work? So let's go ahead and see the implementation, okay, of recursive functions. So many programming languages implement recursion by means of stacks, okay. So as you can see there, so what happened? So generally, whenever a function called the caller, okay, calls another function called the callee, okay, or itself as a callee, the caller function transfers the execution control to the callee, okay. So this transfer process may also involve data okay, some data to be passed from the caller to the callee. Okay, so this implies the caller function has to suspend its execution temporarily and resume later when the execution control returns from the callee function. Okay, so here the caller function needs to start exactly from the point of the execution where it puts itself on hold. Please, very important. Okay, let me repeat myself. I'm saying that the caller function needs to start exactly from the point of execution when it puts itself on hold. So it also needs the exact same data values it was working on. So for this purpose, an activation record or stack frame is created for the caller function. So as you can see there, so this is actually how recursive works. So here we have the function. Okay, so this one is called the activation record keeps. Okay, so this activation record keeps the information about local variables. About local variables, formal parameters, returns address, and all information passed to the caller function. Okay, so as you can see there, so we have our function f of n. Okay, then this one is a stack. So that's how the recursion actually works. Okay, this one is a stack. So if n is equals to 3, okay, of course remember this one is the activation record. Okay, the activation record. So this, let's assume that n is equals to 1. What happened? What will happen? Okay, so here n is equal to 3. Okay, let's just say 3. All right, so 3 then is going to call itself here 3. All right, 3. But remember that the function was something like n return what when n is greater than 1. Return n plus sum of 1, n minus 1. Right, so if n is equal to 3, here we have what n plus this function is going to suspend itself. So it's going to do 3 plus sum of n of 2. Okay, sum of 2. So 3 plus sum of 2, suspend, this function is going to suspend itself. Since we have n of 2, it's going to go up here. Okay, this one is actually f of n minus 1. Okay, and then execute f of 2. Since 2 is greater than 1, you have 2 plus f of 1. It goes again. Okay, now f of 1 is equal to 1. Right, here we have f of 1. So it's going to do what? Return 1 and then return the control back to this function. Remember that 2 were on hold, so it's going to do 2 plus the return value of that f of 1 and then come here. Remember that 3 here was on it was on hold, so it's going to do 3 plus the return value of this one. Right, so that's how the recursive function or algorithm actually works. I hope you got the concept. It's very simple. So now let's go ahead and analyze this. So here we have the analysis of the recursion or recursive function. So here we have some or let's just analyze. If you call this one t of n, so we usually call that for recursive function we usually call them t of n, or of course you can call as you want. There's no problem with that. So we say that if n is equal to 1, then return 1. So this one is 1 time, it's going to execute this one time, and then else return what? N plus sum of n minus 1, which is nothing but gn minus 1. That means mathematically we can take this gn to be equal to n minus 1 plus 1. That's how we get the that time, which is a recurrence relation. So now how to solve the recurrent relations? Actually we have a complete tutorials. We have complete tutorials on which we are going to explain that in more details. How to solve the recurrent relation. Right, so as you can see there, we have this t of n should be equal to this. Then we get, if you solve this one, by tracing or recursively or substitution, we definitely get something like this, right? And then from the previous tutorial, we have big O of n, right? The highest degree. So that's how the time complexity, okay, of this function or recursive function can be, okay, obtained. But now, what is the use, okay, or where do we use, or when do we use which one, recursive or iterative method? So now reuse the recursion as when possible, right? Because here you may notice that it's like, okay, these two functions, okay, that is iterative and recursive, have the same time complexity, that is big O of n. But in sometime it may happen that, okay, the recurrence relation or recursive function always takes lesser time, okay, to execute, okay, some functions, particular specific functions, right? As we are going to see that as we move forward, right? So this was actually to give you a brief introduction or overview of recurrence and iterative method. See you then in the next tutorial. Bye.